We're looking at number 7, determining reactive power from an angle. So this time, because there's an angle involved, I suspect I may need to use some trigonometry, the ratios, but let's take a look and see. A system has a real power of 800 W. So real power is on this leg of the triangle. And they tell me that it is valued in this case at 800 W. And an angle, so they're giving us theta this time. And again, that immediately makes me think SOHCAHTOA. If I know an angle, probably SOHCAHTOA. And they want me to find the reactive power. So which one of these elements is reactive? That is this one. They want me to find VAR. So we don't know about apparent power, nor do we care. I cannot use Pythagorean theorem here because I don't know 2 of the 3 sides in number value. I do need to know the trigonometry value. So I'm going to bring this piece in and help me organize the problem. So hypotenuse, I'll go ahead and color it for you just so you can see it. Doesn't relate to this problem, but it's still there because that's part of the right triangle. I know opposite is VAR. That's what I'm looking for. That's my question. I know the W, the adjacent, is 800. And I know the value of theta is 45 degrees. So I'm going to look at SOHCAHTOA and decide which one of these will help me this time. Well, it's this question and that known that I have. So I know A, and I'm looking for O. So I want the relationship that involves O and A. And that is this one. That's the tangent relationship. So we want to know the tangent of theta, which in this case is 45 degrees. And that is equal to TOA, opposite over adjacent. So the tangent of 45 degrees, let me do this the proper way. As long as I'm just telling you about tangent, this is the tangent of theta. Okay, then we're going to substitute the 45 for theta. And we're going to put opposite, which is VAR, over adjacent, which is W, but I know a number for that one. So I'm going to go ahead and use the number. So to move the 800, I'm going to have to multiply it here. And if I do it to one side, I must do exactly the same thing to the other side. So the 800s will cancel, leaving me VAR. And on this side, I need to multiply 800 times the tangent of 45. So 800 times 45 tangent equals 800. So the missing piece of this picture is 800 as reactive power. Now, once you know that 800, you could find hypotenuse if you wanted to, using the Pythagorean theorem. But it did not ask me for that. It asked me for reactive power. And so that one is done. Number 8, transformer load calculation. A transformer supplies an apparent power of 10 kVA. Don't lose that K right there. At a power factor of 0.9. Determine the real power. So I can plug in a little bit here, but let's be careful. Hypotenuse is VA, apparent, and that's the 10. 10 1,000 VA, kilo, and then they throw in power factor. So I can't tell you the purple or the yellow. It doesn't give me real power or reactive power. It gives me the power factor. And they want us to determine the real power. So what we're looking for is this dimension. So I immediately think SOHCAHTOA, but I can't do SOHCAHTOA because I don't know theta. I just know where theta is. So I can't use trig on this one. I'm going to have to use the power factor formula. And remember, that is defined as true power over apparent power, which we're calling true power W and apparent power VA. Okay. So if we plug in numbers here, we know the power factor. So I'm going to call that 0.9. And we know W is purple, but we don't know what it is. And we know that 10 is our, or 10 kilos is our apparent power. So we'll put it down there. And so we're ready to solve. We're going to multiply both sides by 10 to cancel away, actually 10K, by canceling away. So we're left with 10 times 0.9, which is 9. And remember, those are not W's, they're actually kW's. So 9 kilowatts is your real power, or your W value. And finally, number 9, we have parallel circuit power. Two parallel loads have real powers of 200 W and 300 W, with reactive powers of 150 VAR and 200 VAR respectively. So what that respectively means is that this 150 goes with the 200, and the 200 goes with the 300 because of the order they're mentioned in the problem. Find the total apparent power. So you could work this, you could do one problem for the first parallel load and then another problem for the second load and then combine them. But I'm going to do some math beforehand. So I'm going to say total power is, that's real power, so 200 plus 300. That's a total of 500. And that is which dimension? Total power, real power, true power is this one. So I'm going to plug in 500 W for this one. And then I'm going to find the total reactive power. And reactive power is VAR. So we're going to say 150 VAR plus 200 VAR is 350 VAR. And that is real power, so that corresponds to the yellow element of my triangle. So 350 is here. And that's measured in VAR. So I have a right triangle. I do not know theta, but I know 2 of the 3 pieces, so Pythagorean theorem will work for me here. If I had theta, I could use sine, cosine, or tangent, but I don't have that, so let's not try to do that one. So 350 squared plus 500 squared is the apparent power squared, and that's what I'm looking for. We're looking for VA. So 350 times itself, I'm not going to attempt this one in my head. And I don't have enough light to use my calculators. Let me put on a lamp here. There we go. 350 times 350 is 122,500. And then 500 times itself is 25 with 4 zeros. And that is going to give me C squared. And I'm going to go ahead and tell you right here, instead of C squared, I'm going to use VA squared. So I need to add these two very large numbers together to get 372,500, and that's equal to apparent squared. So take the square root of both sides, and that is plus or minus 610 VAs, approximately. That one is rounded, so I need to use the approximation there. So that hypotenuse, by way of the Pythagorean theorem, apparent power is no longer a question mark. It is an answer.